Good evening, children. Yesterday in periodic table, Daubernier triads, Newland's octavas, and Lothar-Meyer atomic volume curves explanation completed. Today, I will explain complete details about Mendeleev's periodic table. Mendeleev's periodic table. Okay, Nana. Actually, Mendeleev is called father of periodic table. Father of periodic table. Because this person gives a correct detail or give a perfect picture for a periodic table. The perfect picture means he was introduced groups and periods. He was introduced groups and periods. Sir, what are groups, sir? Groups means vertical columns are called groups. And what are periods, sir? Horizontal rows. Horizontal rows are called periods. Simply, just it is a rough diagram for Mendeleev periodic table, because Mendeleev periodic table is not important to us. Just for explanation purpose, I am drawing a Mendeleev periodic table. Rough Mendeleev periodic table. Don't draw in your CW book. Okay, right. So he was nearly 9 groups. 9 groups are 9 groups. 1, 2, 3, 4, 5, 6, 7, 8, and one more, of course, one more. 9 groups are present. 9 groups. Groups means these are the groups. These are the groups, and these are called periods. These horizontal rows are called periods. Okay. Total 9 groups and 7 periods. 7 periods are present in the Mendeleev periodic table. Okay. In those, each group contains 2 subgroups. See here, this is one group. In this group, A and B. Again, in this group, A and B. In this group, A and B. So each group is subdivided into 2 groups, A and B. Okay. Groups and periods. How many groups? 9 groups. How many periods? 7 periods. In each group is subdivided into A and B. Right. Sir, how elements are arranged in the Mendeleev periodic table, sir? Elements are arranged based on their atomic masses. Based on their atomic masses. So the first 3 and this person also arranging the elements based on their atomic masses only. Okay. And what is the law means definition of this periodic table is the properties of elements are the properties of elements. The properties of elements are periodic functions of atomic weights, functions of their atomic weights. Their atomic weights. Listen carefully, all of you. It is means actually, so based on arranging the elements based on their atomic weights. So elements present in the group having the same properties, and the properties are related to their atomic weights. That is the Mendeleev's periodic table definition. Of course, this table is failed, but it gives a boosting to the modern periodic table, and it gives a correct path to the modern periodic table. Right, sir. What about the success of success? Means what are the main points are discovered and main points are discussed in Mendeleev periodic table? Means first one is he nearly arranged 60 elements. He nearly arranged how many elements? 60 elements in his periodic table. Okay, and he leave some gaps for new elements. It is the main important point of Mendeleev's periodic table, because he knows that this actually, for example, if you take one group here, this is one group. In this group, these two subgroups are present, A, B. So, for example, some elements are present here, lithium, sodium, potassium, like that. And in another group, some other Cu, Ag given. For example, A is given, but leaves some gaps. Another element, for example, Pt is present here. Leaves some gap for the new elements. Means some other elements are possible to come to in this group. That's why he thinking very good and leaves some gaps for new elements. Okay. And next one. This is he gave a position to noble gases. What are the noble gases? Noble gases are helium, neon, argon, krypton, xenon, radon. These are all the noble gases. That means before this scientist, means Daubernier, Newlands, Lothermeyer, they did not give any place for noble gases, because of course they did not discover. But this person gave position to the noble gases. Okay, and one more interesting, he gives new names for some elements. This is most important. Aluminum. Simply this is written like this. I think better to write like this. Better like this. Not aluminum. First boron. Aluminium. And silicon. These actually three names are given here. This Mendeleev given three names: boron, aluminium, silicon. But now we are using, instead of these names, this boron name is scandium. Okay, aluminium name is gallium, and silicon name is germanium. Scandium, gallium, and germanium. Okay, Right? Remember these points, all of you. And next point, correction of some doubtful atomic masses. Some doubtful atomic masses. Doubtful means Lothar Meyer, Newlands, they are arranging some elements. That order is based on their atomic weights, but that order is wrong because they calculated wrong atomic masses of those elements. That's why Mendeleev correct that elements and change the order also. One example for this one. They actually arranging like this: carbon, beryllium, and nitrogen. This is the given order. But after that, he was correctly arranging those elements into beryllium, carbon, and nitrogen. Beryllium, carbon, and nitrogen. Just correct that doubtful atomic masses and arranged into a correct order. And how to calculate the atomic masses? Correction of atomic masses. The correction means correct the atomic masses based on one formula. Correct the atomic mass is equal to equivalent mass into valency. Equivalent mass into valency. Based on this formula, he corrected the doubtful atomic masses of some elements. And one more important one, mostly Mendeleev arrange the elements or arrange the groups based on their valencies. Okay, sir. Next one. Yes, these are all the success of Mendeleev periodic table. Right? And some failures are also there. The failures means some doubts arranged by the next scientist and asking so many doubts according to Mendeleev periodic table. He did not correct those questions, and after that they are introduced modern periodic table. Of course, what are the drawbacks or limitations of Mendeleev periodic table? Okay, now listen all of you carefully, because in those drawbacks still some drawbacks are present. Okay, so these are limitations or drawbacks of Mendeleev periodic table. Right, limitations of periodic table or drawbacks of Mendeleev periodic table. First one, position of hydrogen. Actually, Mendeleev could not give a perfect position to the hydrogen atom. Even in modern periodic table also, there is no correct position for hydrogen. The reason is hydrogen, some scientists exist in 1A group elements, some scientists are exist in 7th group elements. Okay, due to it shows some properties of some elements and some properties of other elements. That's why there is no correct position of hydrogen still now. Right? So even in Mendeleev time also, at the time of Mendeleev periodic table, there is no correct position for hydrogen. And second one, position of isotopes. It is very interesting, because we know that what are isotopes? Isotopes means same atomic number but different mass number. We know that what are the isotopes of hydrogen? Hydrogen contains 3 isotopes: H11, H12, and H13. So here atomic numbers are same, but mass numbers are different. Mass numbers are different means how atomic elements are arranged in the Mendeleev periodic table. In Mendeleev periodic table, elements are arranged based on their atomic weights or atomic masses. So means from lower to in ascending order, from lower to in higher, lower to higher. So first element, what is the first element? Least element. What is the next element? Second, third, fourth, means just increasing their atomic masses. And for chlorine, 35, one isotope is present. Chlorine atomic number is 17. Another one is chlorine 1736 and chlorine 1737. Okay, for example, these are the isotopes of chlorine. So which element is coming first? We expected this is the 35. So chlorine isotope 35 is coming first. Next chlorine 36. Next chlorine 37. So before this one, sulfur is present because sulfur is 32 atomic mass, atomic number is 16. After this one, 18th element, that is argon is coming. Argon is 80 and 40 atomic mass. We expected this is the order, but not given these three elements, means these three isotopes in the order. Only he gave only one element, not isotopes. Only one element is given, simply chlorine. So sulfur, chlorine and argon. What about the chlorine isotopes? Why are you not arranging the isotopes, all the isotopes in the table? That is the question mark. Actually, why means this person arranged elements based on their atomic weights. Atomic weights means they are already present in the order 35, 36, 37. Yes, that is the one drawback of Mendeleev periodic table. Actually, this is not a correct one. Why? Elements in modern periodic table, elements are arranged based on their atomic numbers. Atomic numbers, not atomic weights. But Mendeleev arranged the elements based on their atomic weights. That is the problem. Okay, completed. Second drawback. This is the second drawback. Third one. It is very interesting. It is very interesting question. We know that 1 to 30 elements, hydrogen to zinc, and we know that order and also their atomic masses. Sir, argon, potassium, calcium. Argon, potassium and calcium. Argon atomic number is 18. Potassium atomic number is 19. Calcium atomic number is 20. Argon atomic mass is 39.9. Sometimes we are writing 40 also, no problem. Potassium 39. Calcium 40. Once check this order, 39.9 is greater value than 39. After 39, 40 is coming. Is it ascending order? Is it descending order? There is no perfect order. But we know that Mendeleev arranged the elements based on their atomic weights. Atomic weights in ascending order, from lower to higher. But here, higher to lower is present. 39.9 to 39 is coming. So how can you arrange? How are you arranging like this? This is another question mark for and another drawback for Mendeleev periodic table. Simply we can write anomalous arrangement of atoms. Write example like this. Example: argon, potassium, calcium, 39.9, 39 and 40. Okay, sir. Next, fourth point: position of metals and non-metals. Position of metals and non-metals. I understand this one. Position of metals and non-metals in the Mendeleev periodic table is not given. We know that metals, non-metals, metalloids are present. Especially all the elements are first classified into metals and non-metals. But Mendeleev did not give any arrangement or positions of metals and non-metals. This is one drawback of Mendeleev periodic table. And fifth one, position of lanthanoids and actinoids. Lanthanoids and actinoids. Once observe the modern periodic table. This is one sketch. This is modern periodic table. Down, one small table is present. In the modern period. One see in your modern periodic table. So it is divided like this. First one contains 14 elements, second one also contains 14 elements. These elements, the upper elements are called lanthanoids and the outer elements are called actinoids. But in Mendeleev periodic table, there is no position for lanthanoids and actinoids. Especially these elements are belongs to F block only. Only F block elements are present here. So Mendeleev did not give any position to the lanthanoids and actinoids. Okay, Nana? Next one. This is very interesting point. Sixth one. In Mendeleev periodic table, of course, so 9 groups are present. If you take, I am taking only 2 groups. Again, the groups are divided into A and B. Right? So in A, some elements are arranged. In B, some elements are arranged. I think if you grouping any elements means there should be any relation between those elements. For example, in classroom, we are divided into 2 classrooms. One classroom is Spark, another classroom is Smart, based on their marks. In Spark, again divided into 2 parts, girls and boys, based on their gender. Are you understand? So one particular reason is present. Again, similarly, we are applying for Mendeleev periodic table. Mendeleev periodic table is divided into 9 groups, means 9 classes. In that 9 classes, in each class again subdivided into A and B. So we expected in A and B groups present in the same group have any relation. We expected because A and B both are present in the same group. But Mendeleev did not explain any reason, any relation about the groups. Okay, that is another drawback. So the drawback 6 or limitation 6 is no correlation of elements present in subgroups. There is no correlation between subgroups in the same group. That is another drawback. Next one, 7th one. So if you grouping any elements means similar properties elements are keep in the group. That is the reason. That is the main theme of any group. So one same grouping elements have same properties. But Mendeleev arranged dissimilar elements, means that elements having different properties arranged in the same group, and same properties elements are arranged in the different groups. This is another drawback of Mendeleev periodic table. What is that one? Dissimilar elements arranged dissimilar elements are arranged in same group. and similar elements arranged in different groups. Okay, these are the main drawbacks of Mendeleev periodic table. These drawbacks are overcome by Moseley, and Moseley discovered a new periodic table. That is called modern periodic table. So nowadays we are following that modern periodic table only. And Moseley periodic table, the elements are arranged based on their atomic numbers and also their electronic configurations. Actually, Mendeleev periodic table gives us a perfect picture to the periodic table and gives a perfect idea to how to arrange the elements in a period as a periodic table, simply as a table. So that any table is first we divided into groups and periods, and the group elements are having the same chemical properties and same type of nature generally present in group elements. So Mendeleev gives a perfect idea to how to arrange the elements. Only up to Mendeleev time only 60 elements are available, but nowadays 120 plus elements are available. That 120 plus elements are how to arrange as a table and how to remember all the elements. So this person easier the remaining coming persons for the arranging the elements. Okay, this is about Mendeleev periodic table. In the next class, I will explain about modern periodic table. And remember all of you, first I will explain general introduction of the periodic table. After that I will explain the total periodic table. You saw them so many times on the textbooks. In the textbooks also I will explain and practice. Every student must be practice well. Nearly 8 groups and 7 periods are present. Important 8 groups, learn each and every student perfectly. So it becomes easier to chemistry, right? Thank you very much.